Hi there. Welcome to our week one learning guide for differential equations. If this is the first time that you are seeing my face, please make sure it is not the last by hitting that like and subscribe button. That way you get a notification every time a new video is posted. I also put a link to the learning guide below in the description. So if you'd like to download a copy of it, that way you can take notes right alongside me on the worksheet, you can definitely do that. So let's jump in and take a look. This video is going to focus on the separation of variables and following objects. Now, I'll have the other videos for week one linked below as well. That way you can follow along, get all of the examples we have for week one. Let's jump into our first one. We're given a differential equation. We have a dy dx equals y cosine. We're given an initial condition called an initial value problem, and we're being asked to find y equals f of x. Now, something to point out. When your equation has only dy dx and y, no y squared or y to the third, we call that a linear differential equation. You'll want to make sure that you have that distinction in your wheelhouse of vocabulary. That linear differential equation obviously has an order of 1. So keep that in mind as we're working through. Later on in the course, we will, of course, look at different kinds of differential equations. But for this one, the important part is that we need to separate the variables, meaning we got to get all the y's on one side, all of the x's on the other. So I like to go ahead and multiply by the dy dx. And that will give me dy equals y cosine dx. And then I want to get the y on the other side, so I'll divide by the y. Once you have your variables separated on both sides of the equation, then this is where we want to take the integral of both sides. Now, the antiderivative, and I want you to think of this left side as 1 over y times dy. It's going to be easier for us to recognize that antiderivative is the ln of the absolute value of y. And the antiderivative of cosine of x would be sine of x, plus your constant of integration. And this is why you have been given the initial value problem, and that is to determine what the constant of integration is. So we're going to plug in 0 for x, we're going to plug in 3 for y. Let's see what we get. We have the ln of 3, ln of the absolute value of 3 equals sine of 0 plus c. And sine of 0 obviously is 0. So we get the ln of the absolute value of 3. And obviously then the absolute value is not needed because 3 obviously is positive. So we have the ln of the absolute value of y equals sine of x plus the ln of 3. And now we probably want to write this as an exponential. So remember that your ln here has a base of e. So we're going to take it e to this side. And that equals y. Now, e always being positive, that's e to some power is always going to be positive. That's why I can drop the absolute values here. And then I want to think about when we add exponents, we were multiplying the bases before. And then e and ln, inverses of each other, are going to cancel out. And so I end up with 3e to the sine of x as my f of x. Okay. Now, if you are in my section of differential equations, you'll notice my coding here to let you know those examples are going to help you with which assignments in the class. So I hope that helps a little bit of just coding there. Now let's look at the second problem. We have a ball is dropped from the Empire State Building, which is 38 meters tall. We're going to assume the gravitational force is 9.8 meters per second squared. How long does it take the ball to reach the ground? What is the speed upon impact? So let's go ahead and we're going to assume the gravitational force. That is our acceleration. And because the object will be moving back to the Earth, we're going to treat that as a negative 9.8. So we'll look for the velocity then as the antiderivative of the acceleration. And that would give me the negative 9.8t plus the initial velocity, which if the ball is being dropped, it did not have an initial velocity. And then we can take the antiderivative of that to find the position. So that would be negative 9.8 divided by 2t squared. I'm going to use C here. Initial position is what I'm really looking at there. So my initial position, the ball is at the top of the Empire State Building, which is 38 meters I'm sorry, 38 meters. So I know that's my initial position. Now that I have my position equation, we can actually solve for how long it's going to take for the ball to hit the ground. And that's when my position would be 0. So for that first part, we'll set the position equal to 0. And we'll solve, right? All right, so now we divide, I've got 38 divided by 4.9, and then I'm going to take the square root of that. Let's see, I got 2.785 seconds, depending on how many decimal places we're being asked for. And then we're asked for what is the speed upon impact. So we want to know what is the speed at this time. Remember, we have our velocity equation. Velocity is speed with a direction. So we'll take into account that we'll find the velocity at 2.785. We'll notice that it's going to be negative, but speed doesn't have a direction on it. So we'll take the negative off to get the speed. So I've got negative 9.8 and then 2.785. And we get the negative 27.293 meters per second. But remember, for speed, we're going to take that direction off. So our speed would be 27.293 meters per second. So I hope that helps with part 1 of the week 1 learning guide. I will link the next videos in the description below. Please feel free to hit that like and subscribe button and leave me a comment if there's something that I can help with. Bye for now.